Hey guys, want to build a robot? Let's say you've just picked up your ESP32 Voyager or Explorer and you're not sure where to start. Then this video is for you. Today we're going to talk about everything you need to get your robot rolling. This won't be a full in-depth programming tutorial, but we will go through all the steps that you'll need to get your ESP32 connected to your computer and the first few example codes that'll get you started. There is so many fun things you can do with this robot. And if you did pick up an ESP32 Voyager or Explorer from us, thank you so much. You're gonna have a ton of fun. So the first step, once you've got everything assembled, is programming it. This may seem a little tricky at first, and there might be a few steps depending on if you're using a Mac or Windows, but no matter what, it's pretty easy to get started. Let's give it a shot. So the information in this video will be good for the ESP32 Voyager as well as the ESP32 Explorer. Those two robots are almost identical. The only difference is that it has two less motor drivers because it's a two-wheel drive robot and not a four-wheel drive robot. It has all the same features, all the same voltages. The programming software is all almost exact same. And so whether you picked up that robot or this one, this video will help you get started. So if you picked up one of our kits from us, then it came tested from ACBR HQ and you were good to go. But if you soldered one of these up yourselves, one, I hope you had a lot of fun, and two, you may be anxious to test it. So I wouldn't call this robot dangerous. That being said, anytime you're messing with lithium batteries, whether they're LiPo cells or 18650s like we have here, it's just important that you want to follow a couple important rules. So here we have four 18650s. That's going to give us right around 16 volts. So at full charge, an 18650 will have 4.2 volts. And so the motor drivers that we have on this robot can absolutely handle it. That being said, if you did make a mistake somewhere along the line, all you need to do is make sure you know where this power switch is, turn it on, turn it off. Another thing that's going to be really important is that whenever you charge these batteries, make sure they are all the exact same voltage. So I wouldn't get impatient, say you have all of them that are at 4.2 volts and one of them's like 4 volts, not quite there. I would keep them on that charger until they're fully charged and they're all the same voltage. If you don't have all your cells balanced, then the cells can try to balance themselves very rapidly, and that can heat things up and cause a lot of problems. Now, one more thing I'm going to say too as well is if you have the batteries not plugged in while you're programming, right? Because you can keep this off while you're programming, and I'd actually recommend that. You're going to want to make sure that you don't plug in any of the servos, because if you program the servos to move and you turn this on, those servos are going to try to move and pull a ton of current. And if you don't have those batteries, it's just going to try to pull that current from the USB. And that can cause issues, It's not gonna blow up or anything, it's just not a good idea. So in this video, I wanted to talk to you about just all of the different tips and tricks that I've seen. So whenever you're programming, I would recommend not having any of the servos plugged in. Of course, you can have a robot arm attached, just those wires. It's really not a big deal to keep the motors plugged in, because if you have the power off, it's not gonna do anything. That's just my tip for this. Okay, so if you did get this thing put together and you had a lot of fun, then the first thing we have to do is turn it on. And so if we turn it on and see that red light, that means that we are good to go. So with this robot right here, like I said, we have 16 volts, give or take, depending on your charge. And that 16 volts is going into each motor driver. It's also going into this buck converter circuitry. So if you look right here, we actually have two pins that give off 16 volts and ground. And we have two pins over here that give off 5 volts and ground. And so this buck converter, what it's doing is it's taking that 16 volts and it's dropping it down to 5. But because this is a buck converter and not a regular linear voltage regulator, we still have a ton of amperage. And so that 5 volts is going to the ESP32, and it is also going to the servos. And so that way we have tons of power to do all kinds of really fun stuff. So if your robot turned on, step 1 is done. Okay, so step 2 will be connecting it to your computer and making sure that we have connection. If your ESP32 turns on once you plugged it into your computer, then you're ready for the next step. So we're going to be programming our ESP32 Voyager with the Arduino IDE. There are a bunch of different ways you could program them, and you are welcome to try those out. I highly recommend it. But the Arduino IDE is a great way to get started. So this next step that I'm going to go through here is how to add the ESP32 board packages to Arduino. So Arduino is perfect for programming the ESP32, but you have to make sure that you add the ESP32 family of boards into the Arduino IDE. And so that's going to be a really, really important step that we're going to cover right here. Before we get started with Arduino, I want to show you guys just a couple of things. So I wanted to remind you guys that on our website, we have tons of other tutorials. So in this video, I'm going to go over some basic code to get you started. But if you want more examples of what to do with any of our robots, we have all kinds of tutorials on our website. So if you head to that tutorials tab, this one's really fun. So if you're looking for the ESP32 Explorer or Voyager code to work with a PS3 controller that has the robotic arm already programmed in, then this is the place to start. So I cover that in this video here, and also have the example code right here. So if there's something that I don't cover in this video, make sure to check out what we have on the website, because there's always a lot of really, really good information. So the next step here is going to be going to Arduino. So I have this simple example. So this is a simple example code that'll drive the Voyager or the Explorer forward, and we're going to go over that in a little bit. But what we want to do is we want to get this code onto our ESP32. And so there are a couple of steps here. So if this were, if you already had everything set up, and what you want to do is head to the Tools tab. So if I go to the Tools tab and I have some code I want to upload, you see now I'm set up for an Arduino Nano. And that's not what we have. We have an ESP32. And so the first thing we need to do is select the correct board. So before we can do that, if you see here, I have all kinds of boards loaded. You know, there's probably 100 different boards here from different developers. And so if you've never done that, you're not going to have any of these options. And so what we need to do is add in the board files for the ESP32. And the first step there is going to be going to File, Preferences, and right here we see Additional Board Manager URLs. That's crucial. If you hit this little box right here, you'll see that I have, let's see, 5 different URLs for different groups of board managers. So this one's here for the ATtiny, this is for the SparkFun boards, this one's for this really cool edge computing board. But the one we want right here is this guy right here. Espressif.com, package ESP32_index. And I'll leave this on here for a second, or if you want to pause, you can type this whole thing out. But I would recommend just heading to our tutorials page. So we're going to have this whole video in tutorial form that I'll link in the description for this video. And then you can just copy and paste it from there. I like to have guides in video form and in written form on the website, just so there's as much information as possible. But that's going to be your first step. So what you're going to do is you're going to copy that from the tutorial, right, or from this video, and you're going to paste it right in here in this Additional Boards Manager page. So you need to make sure that you have this website loaded and typed out just like this right here. And the good news is it's really easy to tell if it works. So once you have that typed in there, right? And so yeah, also like, just so you know guys, you don't need this MyAxWino, you don't need the ATtiny here. All you need is this one right here. I just want to make sure that's clear. Okay, so you hit OK, right? And only one's going to pop up here, so don't worry about if you don't see that right there. Okay, so then you hit OK. That's that first step. You have the URL set, but you don't yet have the boards added. And so you're going to head over to the Tools tab again, head over to Board, and this time you're going to go to Boards Manager. So click on Boards Manager, and this is how you can add in extra boards. And so if you head over to this box right here, you're going to type in ESP32. And so here you see I already have it installed. Yours, if you haven't done this yet, is not going to say installed. So all you need to do is install it. If you type in ESP32 and nothing shows up in this window, there's probably a problem with that URL you added. So once you've done that though, you are good to go. So you may want to close out of Arduino and open it back up again. But once you do that, if you go to Tools and you go over to Board, you'll now see a ton of other options. So these are the ESP32 options, and there are tons of different options here. So ESP32 is made by different companies, different kinds of ESP32 development boards, and there are a ton out there. And trust me, the ESP32 that I use is just one of dozens that are awesome and have a lot of really, really cool features. That being said, on this whole long, crazy list, you're going to want the Do-It ESP32 Dev Kit V1. So you're going to go ahead and click on that. Okay, so sometimes depending on your computer, it'll take a couple seconds to load. If you hover over the Tools tab and it's not able to click, it just needs a few seconds. Okay, so you've selected the ESP32 Dev Kit 1. That's the correct board. The upload speed, this is default and should remain the same. The flash frequency should also remain the exact same. Don't worry about the debug level. It's not a big deal. Your programmer, keep using the AVR regular programmer. You don't need to change any of that stuff. And so the COM port, this is really important. If you see right here, I have, if I head over to port, I see that I have one COM port open, and that is my ESP32. If for whatever reason your ESP32 wasn't plugged in, you would see that there are no COM ports available. That port would be grayed out. But here I have COM 11. So I'm going to go ahead and click it. You have to make sure to take that extra step to click that. Okay, so now if I hover back over port, you see that I have a check mark right here. And then once I have that check mark, I am good to go. And so now what I can do is I can upload that example code right to my ESP32, and I can get this guy rolling. Okay, so I'm gonna go over this example code here in a little bit, but for right now, I just wanna show you this upload process because there's one extra trick that can kind of confuse people sometimes, but once you've done it once, you can do it 1,000 times and it's no big deal. So just a quick review. My ESP32 is plugged in. My ESP32 is plugged into the Voyager. I've added my board files. My board is selected, right? I have the ESP32 Dev Kit 1. I've got that check mark next to the serial port, and now I am ready to upload. So you're gonna hit that arrow, that's gonna upload the code. It may be a good idea to verify your code, because obviously if your code doesn't compile, it's not gonna get sent over. That being said, once you hit verify, it compiles it automatically, so it's not a big deal. Okay, so do you see how it's saying connecting right here? This is what's kind of weird. You actually have to press the boot button and hold that boot button down for the code to actually upload. So if you don't press the button on the ESP32 while it's trying, it's just gonna say, it's gonna have this message here where it's just waiting, 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 and it's not gonna move. And so it's really important that you press that. If you press that button, it's gonna say leave hard resetting via reset pin. If it says leaving right here, that means your code is uploaded and you're good to go. One more thing I wanna mention too is if your code didn't compile, then you may not have installed the library file. So I'm gonna go over this right now, but this is really important. So if you've written Arduino code before, then you are probably very familiar with the analog write command. And so the ESP32 is really, really powerful. There's an easy way to create a PWM signal, and then there's the correct way. And this is the easy way. And so I just wanted to make this example as easy as possible. So the analog write library for the ESP32, it kind of wraps all those slightly more complicated functions into a nice, easy function. Now, once you start messing with servos, you really want to do it the slightly more complicated way. And I have an awesome tutorial about that in the ESP32 robotic arm tutorial page. Also, if you look at the example code that we have for the PS3 controller with the full ESP32 Voyager and Explorer code, you can see that we actually create the PWM channels and attach pins to those channels and do that more complicated process. But I wanted to show you guys today just how easy it can be. And so the first thing we notice here, I have my library files. And I'm gonna have a link to these library files in the tutorial that we have on our website that's gonna accompany this video. So don't worry about that. You'll install it just like any other library file. And that's super, super straightforward. Okay, then we have our variables. So if you've used a more simple motor driver, like an L29-3D or an L298, then you may be used to the format where you have one variable for speed and two for direction per motor. So if one direction variable is on and the other is off, it'll spin one direction. If you flip that, it'll be the other way around. And so in a lot of ways, the motor driver that we use on this robot makes that process a lot more simple. And so the motor driver we're using here is called the DRV8871, and it is awesome. And so we only need two variables per motor. If you send a PWM signal to one input, it'll spin one direction. If you turn that PWM off and send a PWM signal out of this pin, right, out of to the other input pin, then the motor will spin the opposite direction. And so using only two variables, we can actually control speed and direction at the exact same time. So this is actually for motor 1. These two variables are for motor 2. These three variables, this third set of variables is for your motor 3. And this last set of variables is for your motor number 4. Okay. So all we need to do here is we're creating these variables, and these variables right here, these are referencing the pin locations. So pin 12, pin 13, pin 16, pin 17, pin 23, pin 22, pin 2, pin 15. Those are the actual pins that are hardwired to the motor driver. If you have the ESP32 Explorer and not the Voyager, then you can ignore these last two, because there's only two motor drivers on that. You can also leave it in too. I mean, if you want to use those pins, you'd have to take it out later, but it's pretty compatible. So these are the actual hardwired locations. If you go through the tutorial that we have for the ESP32 Voyager and Explorer, you can actually look at the actual circuit diagram and you could verify yourself that these are the actual pins that we're using for the motor driver. Okay. In the Void setup, these are all going to be outputs, and that's obvious, right? Because we're not taking in any sensor data, we're not using a controller at this point, we're not using a joystick or Bluetooth data. All we're doing is sending signals out to our motor drivers to drive our motors. Okay, so if you guys remember, I'd mentioned that each set of two variables corresponds to one motor. So this is the code to control one motor. This is the code to control your second motor. This is the code to control your third motor. And this is the code to control your fourth motor. Now, if I have the number 255 with the analog write command, that is the equivalent of saying full speed. And so right now, my motor 1 is going full speed in one direction. It's going 0 speed in the opposite direction. Because obviously we can't have a motor that spins a little bit left and a little bit right at the same time, right? And so this is full speed in a certain direction. In the exact same way, we have full speed in that same direction for the other motor. We have full speed in that same direction for that third motor, and we have full speed in that same direction for the fourth motor. And so this will drive our robot forward. Now, if you happen to flip the red and black wires, as you're putting in the robot, then you might notice that one of your motors spins backwards, and you could change that here in the code, or you could just flip that positive and negative. And so I'm going to show here in just a couple seconds how I wire this up, but I just wanted to mention that just in case you were curious about it. And so this code is actually crazy simple. Even though we have a pretty powerful, a pretty complex robot, the bare bones for the code to get this thing rolling is super, super easy. And so before we move on to how this actually looks on our robot, the last thing I want to do is show you how you could hack this and do other things as well. So we know this brings my robot forward. And so if you wanted to, you could make a forward command. And then if you created void forward, and you put all of this that did drive the robot forward right in here, then this code would be the exact same. So I would drive forward infinitely, because whenever I call the forward command that we just wrote in the void loop, it'll execute the forward command right here. And so if I wanted to, I could say I want to go forward for 3 seconds. And then I want to go backwards for 3 seconds. Okay, so obviously we wrote the forward command, but what we need to do now is write that backward command. So I can actually copy and paste this entire thing, change this to backward, and now I feel like it's pretty easy to understand that forward is the opposite of backwards, right? If I'm driving forward, the opposite would be driving backwards. And so what's so cool about this is all we need to do is send it the opposite values. So I had 0, 255, 0, 255, and sure enough, I have 255, 0, 255, 0, 255, 0 right here. And so it's actually pretty easy. And so you could also create a left, you could create a right, you could do all kinds of crazy commands. There's really no limit to what you can do. And like I said, once you have this stuff figured out and you have this working, I would highly recommend you take a look at some of our other examples. And so now that we have written this other example here, let's go ahead and we're going to compile this again, see if I made any errors, which you never know, maybe. Okay, going through that compilation. Okay, so I have compiled my new version of the code, and so I am good to go here. So we're gonna go ahead and go through that upload process. So if you remember, that process was a little bit complicated, but what's nice is if you already have this stuff set up, you don't need to change any of it. And so that makes it really, really easy. And so what I'm gonna do is I'm gonna hit that upload button again. It's gonna compile again, which is kind of annoying, but you know, it's good because obviously it's an important step. So again, I'm gonna show you guys, it's really important that you hold down that button or you press it for a few seconds as this is uploading. Okay, so it's done compiling here in a second. Okay, it says connecting. I'm gonna hold that button down as it says connecting, and I can let go as soon as it starts saying writing. Sure enough, boom, now it is uploaded. Okay, so what we're gonna do now is we're gonna attach the ESP32 Voyager to the tank chassis. We're gonna wire up the motors and we're gonna see if it worked. Okay, so here we have our two tank chassis kits put together. We have our ESP32 Voyager board, and we have all of the hardware we need. Now, this isn't going to be a full in-depth build video on the chassis itself. That we have in a separate video, but we do have that video that goes through each and every step and makes it really, really easy. I'm a huge, huge fan of these chassis, so we use two of the chassis put together for the Voyager and one chassis for the Explorer. So it's super versatile. What's nice is you can even switch around things and move things forward and backward as you need to. And it's really, really easy to integrate into a robotics project. So the first thing that we're gonna do is take these M4 standoffs. So we need 4 standoffs to hold the circuit board off of the chassis. And we're also gonna make sure to use these nylon locking nuts. So that way this thing doesn't roll itself apart. That's one of my biggest pet peeves when you're building robots is when people don't use those or don't supply those nylon locking nuts, because then this thing can just rattle itself to pieces. And so by using that nylon locking nut, it's gonna be really nice and strong. Now, if you want to make sure those are on there good and tight, feel free to use this wrench we included. This is an awesome tool. So this side is for an M3 and this side is for an M4. And so it's really easy to use that just to make sure that your bolts and nuts on there are really nice and tight. It's probably not super necessary, but we want to make sure we include it in case you wanted to use it. The next step is attaching the circuit board to the chassis itself. And that's also a really easy step. All we need to do is make sure to grab our M4s and put a little washer on there. And stick that through the 4 holes on our circuit board. Now, the last step will be plugging the wires for our motors into the connectors right here. All right, we have wired up our motors, we've attached the circuit board to our chassis, we've written our forward then backward example, and we are ready to test this sucker out. So if you want your robot to match the code that we wrote, be sure to follow the same wiring pattern. So here in the front we have black, red, and then we have red, black on that side. That's super easy to change in software too if you'd like to wire it up however you want. That's just in case you want your robot to match what we did here. Because obviously if you're switching the red and black, you're just switching the polarity of your motors. And you want to make sure that all those motors are going in the right direction. All right, let's go ahead and test this sucker out. Sure enough, we have forward and then backwards. So it looks like our robot is ready to go. So I'm planning on going into a lot further detail in the tutorial that we have online, but that's it for this video. Thanks so much for watching, guys. We hope you have a ton of fun putting together your ESP32 Voyagers and ESP32 Explorers.